Hello friends, this question is from the subject of analog in the chapter of operational amplifier. This is a 2 marks question. In the question we have given a circuit consisting 2 op amps and we need to find out the value of VA and VB. And the question they have given as VA which is equal to AV1 plus VB2 and VB which is equal to CV1 and DV2. So eventually we need to find out the value of A, B, C and D. So let's draw the circuit once again. So we have a op amp which have in the non-inverting terminal there is a one voltage source V2 is connected, and from the inverting source there is a one negative feedback, to the VA, and then we have a 1 ohm resistor connected here, and there we have a another op amp which also have the negative feedback, and the positive terminal there is another voltage source V1 is connected. Okay, 1 ohm, and the output voltage is VB, and we need to calculate the value of VA VB. So these are both the op amps are ideal. It is given in the question. So in ideal op amp satisfy the property of virtual ground. So voltage in the voltage across in non-inverting terminal is V2. So the voltage across inverting terminal is also must be V2. Similarly, in the second op amp, if the voltage across non-inverting terminal is V1, so voltage across inverting terminal must be V1. So now, and we also know that the input current to the op amp, to the ideal op amp is 0. It is 0. Similarly, in the case of second op amp also. So, if I can assume the path of a current as from VA, a current is flowing from VA towards V2, and because input current towards op amp is 0, so current will flow from V2 to V1 again towards this 1 ohm resistor and continuously flowing towards this resistor, because again the input current to second op amp is also 0, so same current will flow. So there is a current path from VA to VB because input current to op amp is 0. So now if I can write down the KCL, so current from VA to V2 is same as the current from V2 to V1. So I can write it down as VA minus V2 by 1, which is equal to the V2 minus V1 by 1. So I can reframe this as VA is equal to minus V1 plus twice of V2. Okay. Similarly, if I can write it down the equation for the V2 to V1 to the V1 to VB, so I can write down as V2 minus V1 by 1, because current flowing from V2 to V1 is same as the current flowing from V1 to VB, because current inside the op amp 2 is 0. So V2 minus V1 by 1 is V1 minus VB by 1. So I can reframe this equation as VB is equal to minus twice of V1 plus V2. So now if I can compare these equation to the equation which is given in the question, in the question it is given that my VA is equal to AV1 plus BV2 and my VB is given as CV1 plus DV2. So if you can, I can write it down that same equation here. So it will be my VA is AV1 plus BV2 and my VB is CV1 plus small dV2, then my if I will compare these two equations, then my small a will be equal to the minus 1, small b will be equal to 2, small c will be equal to minus 2, and small d will be equal to 1. So my correct option is option A. So my correct option of this question is option A. Option A. Thank you.